Hi guys, I hope you are all doing well. Let's see today's question. So today's question we have taken it up from this topic of differential equations, and we are continuing our series of questions on JEE Advanced. So today's question we have taken it up from the year 2012, and if I talk about the question here which is given to us, the question says that why is the solution of the differential equation which is given to us, that is y dash minus y tan x, that's equal to 2x sec x, and we have also been given one condition where y of 0 is equal to 0. So this condition will help us to find the value of the constant once we solve our differential equation. So once we solve our differential equation, we'll get a constant, we'll put these values of x and y being 0 and we'll get the value of the constant. So that is the case, and further we have been told that if y of x satisfies this differential equation, then which of the following options will be true? Let's find that out. First option we have been given is y of pi by 4. So y at x equal to pi by 4, it's given to us as pi square upon 8 root 2. Next option that has been given to us is y dash pi by 4, that is equal to pi square by 18. Third option which is given to us is y at pi by 3, that is equal to pi square by 9. And the last option which is given to us here says y dash of pi by 3, that is equal to 4 pi by 3 plus 2 pi square upon 3 root. So these are the four options we need to figure out which out of the four options will be correct, and this is a multiple correct answer question, so there can be more than one answers correct. We need to find all the correct answers here. Let's solve this differential equation first. So to solve this differential equation which is given to us, y dash minus y tan x is equal to 2x sec x. To solve this differential equation, actually there are two methods to solve this differential equation. So let's solve this differential equation by first method and then we'll see the second method as well. So if I try to solve it by method 1 here and try to find the solution of this differential equation, it is given to me that dy by dx minus tan x into y is equal to 2x sec x. Now once I put it in this form, I can directly remember that I can compare it with dy by dx plus py is equal to q. So once I see this type of differential equations of the form dy by dx plus py equal to q, I understand we solved this type of questions previously in the videos as well. So here if I compare it with this, I get p becoming minus tan x and q becoming 2x sec x. Now since both of them are functions of x, p and q, I can just find the integrating factor if as e raised to integral p dx, and we have that with us, e raised to integral of minus tan x. So minus sign taken out of integral. We know integral of tan x is log of mod of sec x. So if I write it in the form e raised to log of something, I can write that as sec x raised to minus 1. So that gives us, we know e raised to log of x is nothing but x directly. Right? E raised to log of x, I can directly write it as x. So if I take this in the base, it becomes sec x in the mod raised to minus 1, that gives me 1 upon sec x. So 1 upon mod of sec x is nothing but my integrating factor if. Once I got if, I can directly find the solution of this differential equation by the idea where we know y into if is equal to integral of q into if into dx plus c. So y into 1 upon mod of sec x, which is a positive value, so I'll write it as sec x next step. Here we get q is nothing but 2x sec x, and integrating factor will be again 1 upon mod of sec x, which is a positive value, so 1 upon sec x dx plus c. So I can directly cancel this sec x from here on the side. Now we are left with y. 1 upon sec x basically becomes cos x, so y cos x is equal to integral of 2x dx plus c. So you get from your y cos x is equal to x square by 2 into 2 plus c. This 2 gets cancelled, you get the solution of the differential equation in the form y cos x into x square. So this is first method to find or understand how to find the solution of the differential equation. So we get that in this form. Now let's try to find the solution of the same differential equation by another method as well. So if I use method to find the differential equation for the question which was given to me, y dash minus I cos x is equal to x, not y cos x, it was y tan x. So y tan x is equal to 2x. So this was the differential equation given to me. Now, if I write it by method 2, I can simplify this or write this as dy by dx minus y. Tan x I can split as sine by cos. And this sec x also I can write that as 1 by x. So if I take that cos on the other side and multiply throughout on both sides, I get here cos x dy by dx minus y sin x by cos x into cos x. So cos x gets cancelled. You are left with y sin x. Here also you get 2x by cos x into cos x. Cos x cancels. You are left with x. Now, the important part in this is to understand that if you take derivative of y and you get y into derivative of cos x, that is minus sin x, and plus you get cos x into dy by dx. Now, if you compare this using UV rule, we get this. This is nothing but the same thing, cos x dy by dx minus y sin x, same as this. So I can write this entire thing as it is nothing but the derivative of y. This is equal to 2x. Now, once we separate this, we can integrate on both sides. So integrating both the sides, I get this becoming derivative and integration are just the opposite. So they cancel each other. You're left with y cos x. Here you are left with integration of 2x, which is 2 into x square by 2 plus c. So 2 gets cancelled. You get that same solution that y cos x is equal to x square. So you get that as same solution of the differential equation which you got in the previous solution. So these are the two separate methods. One, we solved it using our general form of dy by dx plus py equal to q. And the second method, we solved it using just the separation of variables and then using this idea that derivative of y cos x was present. Then we just took the integration, we got the solution. Now, once we got the differential equations solution, now let's just complete this question and solve it. So we have been told that the solution is y cos x into x square plus c. So y cos x is equal to x square plus c. We have a data given to us that y of 0 is equal to 0. That means put x as 0 and that y also becomes 0 at that point. So you get this, you put 0 is equal to 0 plus c. So c actually becomes 0, that is constant of integration comes out to become 0. And your final solution becomes y cos x is equal to x square. If you take x cos x on the other side, you get x square upon cos x, or I can write that as x square. So you have this answer here that y is equal to x squared sec x. This becomes the final solution of the differential equation. So if I write it in terms of y of x, that is equal to x squared into sec x. This is the solution of the differential equation. Now, let's just put all the values which are asked to us in the options and see where we get them as equal. First, we have been told x is equal to pi by 4 and then x equal to pi by 3. So let's check for options A and C first. So if I put x as pi by 4, we get y at pi by 4 is equal to pi by 4 square into sec pi by 4. We know cos 45 is 1 by root 2, so sec 45 or sec pi by 4 becomes root 2. That is pi square by 16. So if I solve this further, I can write that as pi square by 16 into root 2. 16 I can split as 8 into 2 or I can split it as 8 into root 2. And it's cancelled. For option A, we get this value at y equal to pi by 4. Answer as pi square. Now let's put at x equal to pi by 3 as well. Check the C option is correct. Y at pi by 3. If I substitute, I get pi by 3 the whole square into sec pi by 3. Sec pi by 3 is nothing but sec 60, and we know cos 60 is half. So sec 60 becomes 2, and this gives you pi squared by 9. So you get the answer as 2 pi squared by 9. Now let's check whether we have y at pi by 4 equal to pi squared by 2. Y at pi by 3 is equal to 2 pi squared by 9. Let's solve this. Y at pi by 4, I got that as pi squared by 2. So this is the correct answer. Whereas y at pi by 3, we got that as 2 pi squared by 9, not pi squared by 9. So this is not the correct answer. So we have got till now A as the correct option. Now let's check for y dash as well. So when it is telling me to solve for y dash, I can just write this as y dash of x is equal to x square into sec x. So taking differentiation with respect to x using UV rule, derivative of x square is 2x sec x and plus x square into derivative of sec x is sec x tan x. So we get here x and sec x common. We are left with 2 plus x into tan x. So you get this idea for y dash. Now if I find it at y dash at pi by 4, so putting x as pi by 4, you get pi by 4 sec x, that is sec pi by 4, into you get 2 plus x, that is pi by 4 again, and tan of pi by 4, that is 1. So you get this as pi by 4. Sec pi by 4 is nothing but sec 45, which is root 2. Here you are left with 2 plus pi by 4 into tan 45, which is 1. So you get this as 2 plus pi by 4. If you solve this further, to cancel out this root 2, I can write this as 4 as 2 into 2, which is 2 into root 2 into root 2. So 1 root 2 gets cancelled, you're left with root 2, and you get your 2 plus 5. So you have this entire expression at y dash pi by 4. Get pi by 2 root 2. But that's not the case which is given to us here. So this is ruled out. So if I multiply also, you get this becoming pi by root 2 plus pi square by 4 into 2, that is 8. So you get this entire expression, but you have been given only one expression in the option B. So that's for sure not the correct answer. Now let's also find y dash at pi by 3. So if I put at x equal to pi by 3, I get this becoming pi by 3 into sec pi by 3, which is sec 60. Here you get this as 2 plus pi by 3 into tan pi by 3, which is tan 60. We already know tan 60 is root 3. So if I write this pi by 3, sec pi by 3 is 2. Here you get 2 plus pi by 3 into tan pi by 3 or tan 60 becomes root 3. So you get this, if you solve it further, you get that as 2 pi by 3, 2 plus pi by. So what I did was I just substituted 3 as root 3 into root 3. So this 1 root 3 gets cancelled. So you're left with 2 plus pi by 3. If you solve this further, you get this 4 pi by root 4 pi by 3 plus 2 pi square by 3. So if you solve and see and check this, got that as 4 pi by 3 plus 2 pi square by 3. So this is also the correct answer. So from this question, we understand that there are two correct answers to this question, and those are options A and D. So these are the two correct answers. I hope you have understood how to solve this type of questions, where we have been given such differential equations for which we found the solution and just then put the values for x as pi by 4 or pi by 3. Then again taking the derivative and putting x as pi by 3. So we got two options correct, A and D. I'll see you again tomorrow with some other question from some other topic. Till then, you can like, share, and subscribe to my channel. Also, do share these videos with your friends who are also involved in this preparation of JEE Adv. So they can also take the benefit from these questions which we are solving. Thank you.